Hi guys, welcome you all to my channel Explore Edu to Teach.
So the next topic that we'll be covering today will be R2R ladder DAC. We have already covered in the last class another kind of DAC called as the weighted resistor DAC. As you can see over here, it is already uploaded in my YouTube channel playlist for digital electronics. You can go and watch it from there. As we learned in the DAC that it is a kind of DAC in which converts the analog digital to analog converter. However, the resistor however, what can happen is that the number of resistors can be an issue in that case for higher number of bit. Hence, we are coming to another kind of ladder circuit for DAC called as the R2R ladder resistor, in which we have only two kind of resistor, the R or the 2R. Like in case of your weighted resistor, for n bit we require 2 raised to n resistor. So for 50 bit we require 2 raised to 50 resistor value, but that is not possible in actual scenario. So in case of R2R ladder circuit, we need not worry about that. We'll be just be sticking to the R and the 2R. There is no other value else from that, may it be any kind of n bit kind of DAC. So let's try to understand the R2R ladder DAC. So what do you mean by R2R ladder DAC? The R2R ladder DAC basically converts my digital input or the binary input into my analog output. Okay, there are only two kind of resistors. One is the R, the other one is the 2R, and it basically is a inverting adder kind of circuit. So if you just look at the diagram, we have this resistor 2R, R, 2R, R. There is a feedback resistor of 3R. However, apart from that, all the resistors are of 2R, R, 2R, R, 2R and 2R. So the values of this resistor remain the same. Hence, this is called as the R2R ladder circuit. Now, if you consider, here you have different bits A1, A2, AN. A1 is the MSB bit and the AN is the LSB bit. So if I just consider the input as 1, 0, 0, the 1 is the MSB bit, that is the most significant bit, and 0, 0 is the less significant bit and A3 is the least significant bit. So if I just have to convert this diagram according to the input given, my A1 is connected to minus V reference, okay, because it is 1. A2 and A0, A3 are the 0 values, so it is directly connected to ground. Hence, you can reduce this circuit as this, because 2R becomes 2R becomes R, the R and R becomes 2R. Then you have the 2R and 2R again becoming R, and the R and R becoming 2R again. So just it's a series parallel game. You will get 2R over here, you have 2R over here, you have minus V reference, you have 2R, and then you have the 3R. Just apply the voltage divider rule and you will get this as the final diagram. When you apply the inverting circuit formula, in which your V out is equal to minus of R reference upon R in into V in. Therefore, you have minus of RF upon R1 into V in. The RF is equal to 3R. If you see in this case, the R1 is equal to R plus 2R 3R, and the V in is VR minus VR by 2. It is a negative, right? So finally, we have VR by 2 as my output voltage. I hope I am clear with this. So this is my R2R ladder circuit, in which we have two kind of resistors, the R and the 2R. It's basically used to convert my digital input into my analog output, and it's an inverting kind of circuit, right? Okay. So let us try to solve one numerical on it, which was asked in GATE 2007 EC paper. It's a very good numerical on R2R ladder circuit. When we solve this numerical, you will get very good insights of this kind of circuit and how do you need to solve problems on it. So if you see, what did the question say? The question said, in the given DAC, the VR or the reference voltage which is given over here is 10 volts and the R is 10k resistor. Okay, find out the V out and the I. So first we'll try to find out the value of I, which is given over here. Now if you know by the virtual ground concept, my non-inverting terminal is connected to ground. Since this is an ideal op-amp, considering that my inverting terminal can also be considered as ground, therefore my this terminal and my this terminal can be connected straight away to ground. Hence I have a V reference voltage. We have 2R, we have R, we have 2R, we have a R, we have a 2R circuit, we have a R circuit. Then again there is a 2R resistor over here which is connected to ground. Then there is a 2R over here which is connected to ground. Now what happens is that we have to find out what is the current going through this particular resistor. Hence what we are going to do is that we can conclude this entire circuit onto the value 2R. How do I do it? If you see from the right hand side, the 2R becomes R because they are in parallel. Again this R and R in series becomes 2R. This 2R will again form in parallel with 2R will give you R. The R and R becomes 2R. 2R and 2R in parallel becomes R, and you have finally the 2R. So just apply the series parallel rule from the right hand side and you will get this value as 2R. Fine. Now what happens is that the VR is given as 10 volts and the R is given as 10 kilo ohm. Therefore the I1 which is there is given as VR by 2R, that is 10 by 20k is 0.5 milliampere. So the current over here is 0.5 milliampere VR by 2R. Since if you see 2R and 2R are equivalent resistance circuit, the current will get equally divided. So here you have 0.5 milliampere and here also you have 0.5 milliampere. Similarly, the 0.5 milliampere, again if you see, we can divide it into two parts because the equivalent resistance 2R will be, and this equivalent resistance will also be 2R itself. So it gets divided into two equal parts again, 0.25, 0.25, that is 0.5 into 2. Again 0.25 divided by 2 becomes 0.125, 0.125. Again this 0.125 gets divided by 2 and you get 0.0625 milliampere and 0.0625 milliampere, which is equal to 62.5 microampere, right? So the current I which is mentioned over here is equal to 62.5 microampere. So I hope I am very clear with this. Okay. Now what is the next question saying? What is the output voltage? So if you see over here in this circuit, just reproduce this circuit. I have drawn this circuit once again over here. If you see now the current coming over here is 0.25 milliampere and the current coming over here is 0.0625 milliampere. Hence I can say at this point it is 0 because the non-inverting is connected to ground, hence the inverting also connected to ground. We have 0 minus of V out upon R is equal to 0.0625 which comes from here and 0.25 comes from here will enter into this resistor. There will be no current entering into the input terminals of the op-amp because the equivalent resistance input resistance of op-amp is infinite, hence the current is also equal to 0. Therefore your 0 minus of V out upon R is equal to 0.25 plus 0.0625, and then find out the final value as minus of 3.125 volts. So I hope I am very clear with this and you have got a clear understanding about the thing. So you should understand these things very well in order to get a better understanding about the concept. If you have it, it's going to be easier for you to deal about. I hope I am very clear with this. Okay. So in this question, if you just apply the basics, you can always try to find out the answer. The notes are present down in the description box itself. Also, I am uploading all these circuit diagrams in short, which is going to be very helpful for you for a quick revision during the time of your exams on my Instagram page as well. The links are given down in the description box. You can check my post on my Instagram page, and if you like it, you can follow me over there as well. Subscribe to my YouTube channel and share it to as many people as you can. Thank you so much guys. God bless.